So hello, welcome back. Long time no see. Dmitry is back with his PowerPoint and a new speaker, Andy, and they will speak about JSON support in Jakarta EE right now and then about the future. So I hope JSON-P, JSON-B, and I'm really curious about that. So please share your screen and I will just disappear right now.
Okay, let me try. I hope my PowerPoint won't crash again. Oops. It works now. Okay. JSON support in Jakarta EE, present and future. A little bit about ourselves. So my name is Dmitry Kornilov. I'm from Oracle. I'm Jakarta JSON processing and JSON binding project lead. I'm also Eclipse for JPMC member. And I have another speaker, Andy Gibert. He's from IBM, and he's Jakarta JSON binding project lead too. So we have two leads in Jakarta JSON binding project. Agenda for today, I will do an introduction about the JSON, what JSON is. After that, we'll talk about Jakarta JSON processing, introducing a lot of features of JSON processing. Next is JSON binding, the same thing about JSON binding. And at the end, I will pass to Andy, and Andy will present new features of JSON binding, which we are planning to add to the next version of the spec. So first three bullets is actually present, and the plans is the future stuff they are planning. Let's get started. The usual safe harbor statement: you should not make critical business decision based on this session. And coming to their introduction. What is JSON? So I think maybe I don't need to explain what JSON is, but we're talking about JSON, so let me do that. So JavaScript object notation, open standard, RFC 7159. And 8259. So I put two here because 8259 is the latest one, and 7159 is actually what is used in the spec. So which is what we actually support. We don't have support for 8259. Possibly we'll add it to the new version of the spec. JSON is text-based, so here is a sample here. It's language independent. It's very nicely readable by humans. And it's supported in most of languages, possibly all languages, so which makes it very attractive as a lightweight data interchange format, so which I think all of us is using it for. JSON supports three primitive types: string, number, and boolean. Two structure types, which is array and object, and null. So in this sample, you can find all of them. So strings are here, John and Dob in their quotes with our strings. Number without quotes, which is age. This is a Boolean value. Null is here, and array is in square brackets. I have contacts array here with only one element, and object is in curly brackets. Basically, this whole stuff is one object, and another object is one of the contacts home number. How JSON is supported in Jakarta EE? So we have two APIs. One is Jakarta JSON processing, and another one is Jakarta JSON binding. And JSON processing is a low-level API. It's basically a parser. It's used to parse, generate, transform, and query JSON. It consists of two APIs, similar to DOM and stacks, if you're familiar with an XML world. And Jakarta JSON binding is a higher level API, and it's used to bind the JSON documents to Java objects. It actually uses JSON-P itself. And it's, if we started to compare it with XML world, so it's similar to JasonB. Let's talk about JSON processing. Here I collected some useful links. So when you browse the slides offline, you can click them. I think it's quite convenient. I'll upload the slides to SlideShare after this presentation, immediately after that, and post a link to the chat. So Jakarta JSON processing is Jakarta project. So it's hosted by Eclipse Foundation. It's on GitHub. So our website is actually GitHub pages of our repository. So you see Eclipse E4J here, JSON-P. Repository is, again, as I said, in Eclipse E4J organization. And here is a link to Eclipse project where you can check the Eclipse site related to JSON-P Eclipse project. And here is a link to a mailing list. So if you would like to be updated, then join it. Okay, JSON processing has two APIs, streaming API and object model API. What's the difference? Streaming API is event-based. So it's basically mainly used when you have some stream of JSON and would like to process it. You can have access to only one element at a time. It's efficient for high volume of data, and it has a very small memory footprint. So similar to stacks. An object model API is similar to DOM, there, or your JSON document is loaded in memory, which gives you an advantage to random access to elements. But on the other hand, it's not efficient for the big documents because it can eat all of the memory. But for small documents, it's perfect. And here are the classes, which actually I will talk about later. So only two in streaming API, JSON Parser and JSON Generator. And then object model API, there are more: reader, writer, pointer, page, and merge page. So reader for reading, writer for writing, and pointer, page, and merge page for basically querying and updating JSON documents. Let's start with streaming API. Two classes, JSON Parser, JSON Generator. Start with Parser, right? So JSON Parser parses JSON in a streaming way from input sources, different input sources supported, similar to stacks, mentioned it already. XML stream reader, right? So this is what it's similar to. You can create it using a factory method, JSON.createParser or JSON createParser factory createParser. What's the difference? First of all, in JSONP, there is a JSON class, which contains quite a lot of factory methods to create everything. So if you don't know what to do, if you need to create something you don't know how to create, the easy point is in your IDE type JSON dot, then your IDE will suggest what you can do, right? Difference between these two is create parser, just create a parser with all overhead of creating that. But if you want to take advantage of caching, then or reusing your instance, then you should use the second one, create parser factory, create parser. You can pass actually some parameters there, like configuration. Configuration is implementation dependent. And then you created the parser, and it will start parsing the document, and it erases events when it finds a token. And the list of events are here. So start array, start object, key, value string, value number, and so on. I'll have a nice demo demonstrating you so you understand it better. Imagine that we have this kind of document. And when we start parsing of this document, parser, first of all, it finds the curly bracket, right? In this case, it erases start object event, right? It goes next. Next is a key, so key name event is erased. Like the next one, value, and actually value string is string value, so value string event is erased. New key, in this case, here is a number, so value number event is erased. So basically, the kind of type is coded inside the event name, right? Another key here, and here we meet the first square bracket, so it starts the array, so start array events erased. Another object, another type, another string, another type, sorry, key, of course, another string. Here we have a closed curly bracket, so it's end object. Here we have a closed square bracket and array, and the last end object. So this is basically demonstrates the concept of how event erasing works. How it looks in Java. In Java, it looks like that. So you create your parser using, I use the first method for simplicity, JSON.createParser. And after that, you do parcel.next. It moves the pointer to the next token, to the next element of your JSON. So basically, event is start object in this case. Token is here, right? Parcel Next jumps to the key. Key name is raised. To read the value of the key, you can use parcel.getString. So name will be returned. And so on and so on and so on. So to read the value number, so when we're here, you use parcel.getInt, right? So it's a number value. So to get a number, use get whatever number. I thought it's clear, so it's very easy. That's it about parser. Now let's talk about generator. If parser reads JSON data from stream, generator actually writes data with stream QA. And it's similar to Stax's XML stream writer. Parser is XML stream reader, generator is XML stream writer. There are two ways to create it. Again, create generator with all the overhead which goes by creation of the object, or create generator factory, create generator. In this case, please use it, then you want to reuse, for instance. You can pass some parameters to create generator to the second method, like pretty printing, and some other parameters, implementation dependent. And it uses the builder pattern, and here comes a sample. So this code generates this JSON document. So it's an array of objects, right? So we create JSON generator, and after that, see the builder pattern. Nice builder pattern is here. So you do write start array, which writes square bracket, write star object, which writes curly bracket. After you use a variety of write methods with key value, right? And after that, you just do write end, and the generator automatically puts a proper bracket there. So if you are inside the object, it uses closing curly bracket. If you are inside the array here, it puts the closing square bracket and close it at the end. Very easy. That's it about streaming API. Now let's talk about object model API. And it's similar to DOM, as I was saying already. And it has a builder to build JSON object and JSON array from scratch. It's type safe, so you can't mix array and object building methods. And you also can use existing JSON object and JSON arrays in the builder. So you build something and you want to include another existing JSON object there, so you have an ability to do it. Here comes the sample. So this code using JSON object model API to build this document, the same sample as JSON generator. And actually, the code is quite similar. So you create array builder using JSON, our static factory method. You add there a JSON object, which you build using object builder, which you create using another static factory method of JSON object, right? You add your key values there, and after that you build the second one, and so on, and you build the result at the end. And it builds it in memory, right? This is a DOM model. This is how it works. Another thing supported by JasonP, and here we are coming to features which were introduced in JasonP 1.1 spec, right? So all previous stuff was a part of JasonP 1.0, and JSON Pointer, JSON Page, and JSON Merge Page are a part of JasonP 1.1. So JSON Pointer, it's an open standard, RFC 6901. And it's just a syntax of identifying a specific value inside your JSON document. Something similar to XPath, but simpler. So it always starts with a slash, means root. And after that, you put a property, and if it's an object, a property of this object. So it's very easy. If it's array, then you put a number there, and array counted from 0. So 0 is the first element of array. So this pointer points to the first element of parents array. And special characters is actually slash, which is converted to tilde1, and tilde, which is converted to tilde0. It's better to demonstrate it using a sample. Imagine that we have this kind of JSON document. And what we want to do here, we want to take the second element from the list, which is Jane, right? And replace her last name to Doe. It doesn't have it now, right? So what are we doing? We are creating a pointer to this property. How to do it? From the root, we take a second, one means second, first, second element of array. And we are taking last name property from there. So this is our JSON pointer. And we create JSON pointer again using our favorite factory method of the JSON class here. To replace the value, we call pointer replace, pass the original object and what to replace it with. We're replacing it with string Doe. And to check the result, we read it back, right? So we do pointer get value and pass in there from which object we want to get this value. And it should return the new updated value, which is Doe. So you see that it's very easy to use. Next feature, JSON Page. Again, open standard, RFC 6902. And JSON Page is used to modify parts of JSON document. Imagine that you have a big JSON document, then you have a patch, which actually a JSON document itself, and it has a special defined syntax, which consists of elements, and each element has operation, path, and value is optional because of some operations like remove, for instance, doesn't need a value. So operation is operation from this list, add, replace, remove, move, copy, test. And path is a JSON pointer to the element to process, right? So basically, inside the patch, we can code whatever operations, modifying operations we want. I have a sample for that. We have this original document. Again, this is a list of some people. So we have John Doe here, we have Jane Doe here, and you see that we have John Doe duplicated here, right? So this patch consists of two operations. And the first operation is replaces the last name of a second element with Doe. Basically the same what I was demonstrated in JSON Pointer. And the second operation is removing the last element, the third one, which we don't need. So look, to change the value, we're using the replace operation. We are providing path to our property to change. Second element of the list property last name. And we provided a new value Doe. This is what I've done in JSON Pointer demonstration. And the second operation, remove, and we're providing a path to the element, pointer to the element to remove, which is third element, and it will remove it. Very easy. And here is how it looks in Java. So we can create JSON patch using JSON patch builder in Java. In this case, we don't need any JSON document, we just build it. And we can build it using create patch builder method, factory method in JSON class. Operations are coded by method names. So there is a replace method, there is a remove method, add, and so on, and provide parameters there. And you can apply a patch using patch apply, and you provide an object to apply it to, right? So it's very easy. Another option is to read the page data from the external document. And in this case, we are using JSON reader. So we're creating it using JSON.createReader, providing some parameters here where to get the data and do read array. It will read our array, this array, patch array, into memory. And after that, we create a patch based on that, like this, JSON create patch, and apply it the same way as here. Okay, that's it about JSON Page, and actually we support another page called JSON Merge Page. It's another standard, RFC 7396, and Merge Page is different from the previous page I demonstrated because this is like a Git-like merging, right? So your page is a JSON document itself, having the same structure as your original document. You just provide some changes there, and these changes are merged into your original document. Again, it's Git-like experience. You can create merge page using the same patterns, like a factory method in a JSON class, and you create a merge patch based on this data, and you apply to some document using merge patch.apply. And I have a sample for better understanding what JSON merge patch is. So imagine that you have a source document. It has 3 fields: first name, last name, and address. And you have a patch, right, which you want to merge. Then what this patch has, it has a new value for last name. It's empty, this has null. It has a new property age, and it sets address to null, which is equivalent to delete. And if you merge that with this one, you will get this result. So first name is untouched, last name is changed, age is added, and address is deleted. So this is how JSON merge patch works. That's it about JSON processing. So JSON processing is very small and easy to use API, actually, and low level, which you can do with JSON wherever you want. Now we're coming to JSON binding, which is a high level API. And let's just do some quick introduction again. So it's API to serialize, deserialize Java objects to from JSON documents, similar to JasonB, except JSON is used instead of XML. When we created JSON binding specification, we tried to standardize the most useful features of another binding frameworks like Jackson, Genson, and JSON. So we took some heavily used functions there and standardized them. Actually, guys from Genson and JSON were a part of the expert group, so we worked together on the standard. So there are 2 features of JSON binding. First of all, we try to make it nice by default. So it supports most of Internet JSON, iJSON features by default. But it also has a rich customization API based on annotations or at runtime. And JasonB is a natural follow onto JSONP. Actually, if we talk about the history, JasonP, I think, was introduced as a Java EE 7. And Java EE 7 had only JasonP, but didn't have JasonB, right? And when JasonB was introduced in Java EE 8, we kind of covered the JSON support, right? And JasonP is using JasonP itself. JasonB is a high-level API, and it uses JasonP for the low-level JSON operations. And it also allows to use different JasonP providers. Right? Okay, here are some links. I think I don't have much time to go through that. Basically, this is the same what I demonstrated for JSON processing: website, repository, Eclipse project, and mailing list. Use it when you browse the slides offline. Now I will talk about default mapping, and the next section is customizations, right? So default mapping, this is how JasonB defaults by default when no customization is present. So no configurations, no annotations. JasonB with default settings can be created with one string operation: JasonB builder create. That's it, you have JasonB. If you want to reuse it, cache it. Don't use JasonB builder create again, because this is expensive. The scope of default mapping. This is how spec says, right? So I'm talking about the spec. In spec, default mapping is defined for basic types, specific JDK types, dates, classes, collections, arrays, enumerations, and also JSONP model classes supported. Let's talk about this a little bit more. But before that, you've seen here that JasonB engine is created. So here I explain what methods JasonB has. It's an interface which has a variety of from JSON and to JSON methods. Very easy. To JSON is used for serialization, and from JSON is used for deserialization. And here you see some different sources and targets. Sample. I remember I was demonstrating how we create that using JSON Generator and JSON Array Builder, JSON Object Builder, and so on. Now I demonstrate how to build it using JasonB. First of all, you create a model, your person class, which is John Doe, put properties there. Your second person, Jane Doe, put the properties there. You create your array, you put these two persons into the array. Then here, actually, the binding parts comes. You create a JasonB, and you call JasonB to JSON and pass there this array. That's it. It's very easy. And it will produce with JSON. So this is the preparation part. This is actually the binding part. OK. I was starting talking about the scope of default mapping defined by the spec. And I was saying that it supports basic types and specific types. So what actually the types are, right? So basic types, primitives, and corresponding classes. Specific types, big integer, big decimal, URL, URI, and optionals. DateTime. Here is a table. It's going to be small for you, right? But I wanted to put everything into one slide. So these are the DateTime classes supported by the spec. And here are the formats used by these DateTime classes. The formats looks different, but if you see, all of them are ISO formats. And it's one of the iJSON requirements that date times are serialized and deserialized using ISO formats. So we're using ISO formats here. If I use calendar and the time portion is not present there, then it's not present in the corresponding JSON document. Here I have a sample. So Java util date. OK, don't use it. You should use the local date, definitely. But for some reason, I don't have it here. So Java util date. You use this format, and then you serialize it. The result is going to be this. Calendar without the time portion. The result is this. ISO format, right? Instant, duration, period. All of these are ISO formats. Arrays and collections. Actually, spec defines all arrays and collection classes it supports. All of them are listed here. For some reason, when we created the spec, we missed the num set and the num map there, right? So we're adding it to the JSON bit next. There is nothing more to say about collection, just supports it, right? And JSONP types. So these JSONP types are supported. So it's value, pointer, string, number, object, array, and structure. And this is a sample demonstrating how JSONP types are processed. So you create your JSON object here using JSONP. So this is JSONP stuff. And after that, you use JasonB to JSON, and you pass your JSON object there, and it will serialize it to string. So this is kind of funny sample, but I just wanted to demonstrate interoperability between JSONP and JasonB. Classes. What kind of classes support? So public and protected nested and static nested classes supported. Anonymous classes supported only for serialization. Inheritance is supported. And default no argument constructor is required for default deserialization. So if you don't have it, the process will fail. What kind of fields are supported? Final fields are only serialized. Static fields are not supported, they're skipped. Transient fields are skipped. Null fields are skipped too. So we're not serializing fields given null values. There is a very special customization for that called JasonB nullable. I'll talk about it later, which enables serializing null fields. By default, the field order is lexicographical. Lexicographical means from A to Z. And in case of inheritance, parent class fields are serialized before the child class fields. I'll call it that JasonB respects parents. Here I have a sample. So I have a parent class with two properties, parent B and parent A. Default serialization produces this JSON document. You see that parent A is before parent B. So it's sorted out alphabetically, lexicographical order. More complicated case, we have inheritance here. So we have a child which extends parent, has two fields, child B, child A. If we serialize it, it will produce this document. No, without the empty line, right? You see that JasonB respects parents. So it puts parent properties before child properties. And inside each class, properties are sorted from A to Z. Parent A, parent B, child A, child B. So that's the default behavior. It can be customized, can be changed. I'll talk about it in the customization section. Now, scoped field access strategy. It means that how we get properties, right? And this description can be a little bit complicated. I can simplify it the way that JasonB respects getters and setters. So if there is a getter, it will use it for serialization. If it is a setter, it will use it for deserialization. JasonB also respects visibility of fields. So if setter or getter is private, then this property is going to be skipped, right? For instance, we're trying to serialize some property which has a private setter. It won't be serialized. And it supports properties without getter setters too, respecting their visibility. And in case we have a pair, getter and setter, without a corresponding field, it's supported too. Here I have some sample and to demonstrate that. So I have a class called foo with kind of properties with self-described names, right? So this property is public final, right? Public final field. And when we serialize this class, it will produce this JSON document. And some fields are not going to be supported. So let's just go through and see why. So public final fields is supported because it's public and final fields are supported. The next one is private final field, is not serialized. Not serialized because it's private and JasonB respects visibility. Public static field, not serialized because JasonB doesn't support static. Public with no getter, just a public field, is fine. No getter and public, so we respect visibility, public, so serialized. Public with private getter, this is kind of a funny situation. They have a public property with private getter, but it won't be serialized because JasonB respects getters and setters first, and it found a private getter and it skips the property. This property is skipped because it's null. And private with no getter, again, not serialized because JasonB looks at the getter, there is no getter. JasonB looks at the field, it's private, and it respects visibility. Private with public getter, which is standard case, serialized. And this is a pair of getter and setter without actual field. And because getter is public, then this property is serialized. It looks a little bit complicated, but at the end, it's actually very easy. This is how Java works. Customizations. So there are two ways to customize your binding. You can customize it compile time using annotations, and you can customize it using runtime using JasonB config. And here I listed all JasonB config methods which you can use for your customizations. And to apply your customizations, you need to actually build a customized version of JasonB engine. And in order to do that, you use JSONB builder. But instead of create, which creates a default configuration, you use new builder and pass their configuration you just created before, right? You also can change your JSON-P provider here, right? So which builds the customized JSONB engine. All right. So what customizations are supported? Property names, property order, ignoring properties, null handling, custom instantiation, property visibility, quite a lot of stuff, right? I'm slightly running out of time, so I'll just skip it and quickly go through these customizations. Otherwise, Andy won't have enough time to talk about future plans. Property names. The standard stuff you do. You don't want to use standard property name. You want to use some different, right? JSONB property annotation. If you put it on field, it affects both serialization and deserialization. If you put it on getter, it will affect only serialization. If you put it on setter, it will affect only deserialization. So we support funny use cases where you can serialize the same property using different names. You serialize it using one name, you can deserialize it using another name. Again, this is kind of funny stuff. If you want to change how to process names globally, we support a feature called property naming strategy. And in this case, the same rule will be affected to everything, right? We support some predefined strategies, and you can create a new one and pass it at runtime to JSONB config, right? Here is an example how to do it. A list of strategies we support, there's quite a few of them, right? And the sample actually demonstrates how your property will be changed. So identity is default one, it means no change to the property. Lowercase with dashes converts my property to this, my dash property. Lowercase with underscores, that. Camel case with spaces. Case insensitive, basically this is the same as identity, but it ignores case on deserialization. So you can have your in JSON document some kind of a funny mixed case stuff, and JSONB will try to find the property in your document which corresponds to that, ignoring the case. And custom, you can write your own strategy, whatever you want. You can change property order strategy too. Default is lexicographical. Two other are supported, any and reverse. Any means that property is not defined. In the most cases, it will be how your properties appeal in your class, but it's not guaranteed. And reverse is reverse to lexicographical from Z to A. We have a special annotation, JSONB property order. Here's a sample, put it on class. And in this case, any is used. So basically no property order defined, which can give you a little bit of performance, but just a little bit. Ignoring properties is another standard use case. You can use, you can use transient keyword, but sometimes you don't want to use it. So JSONB transient annotation. Put it on field and it will be ignored on serialization and deserialization. On setter, it will ignore it during deserialization. On getter, it will be ignored during serialization. Visibility. So I explained that JSONB respects getter setters, blah, 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 this kind of stuff. Everything can be changed if you define your own visibility strategy. We have a special interface, property visibility strategy. You implement your strategy based on that interface. You plug it in using JSONB visibility annotation on type, or at runtime using JSONB config with property visibility strategy method. Null handling. By default, JSONB doesn't process null fields. If it's a problem, it can be customized using JSONB nullable annotation on class. In this case, all fields will be, null fields will be serialized. You will have in JSON name null, right? Or on the property level, you should use JSONB property with nullable true. So it's a second parameter of JSONB property. First is the new name, but if new name is not specified, the name is used. And nullable true means that if it's null, it will be serialized. You also can define it globally using JSONB config at runtime with null values true. Custom instantiation. That's actually interesting stuff. It can be used if, for instance, immutable object, you don't have a default constructor. You have some other constructor, right? In order to switch it on, you put JSONB creator annotation on your constructor, and you define your parameters using JSONB property. In this case, the values of constructor parameters will be read from your JSON document. So here's a sample. We have order, which has a customer, and customer using custom instantiation with JSONB creator. So when customer is created, we have a parameter called ID. It's here, it's 562. So this is going to be passed to the constructor to create a customer. There are abilities to change date number formats, and there are two methods for that. First of all, annotations on fields, JSONB date format, JSONB number format, or you can change it globally for all DateTime fields and number fields using JSONB config with date format or with locale. Binary encoding. If you have some binary data, we support free encodings, byte, base64, and base64 URL. Byte is default one. If you want to change it, runtime only, JSONB config with binary data strategy. iJSON, I mentioned it already. So iJSON is Internet JSON, which is a restricted profile of JSON for internet communication. Open standard, again, you can see draft here, right? We tried to make JSONB default mapping compatible with this format, and it is, with 3 exceptions. These exceptions are listed here. I'm not going to list it here because of the time issues. But if you want your document, you want to switch on the full iJSON compatibility by passing with strict iJSON through to JSONB config. In this case, these 3 will be kind of checked, and if you have something wrong, exception will be raised. Another 2 is really kind of hardcore customization stuff, adapters and serializers, deserializers. Basically, it will allow you to do mostly everything. Adapter is a special interface where you code your conversion rules from one class to another. If you don't like how first class is serialized, you create an adapter to another class which you like how to serialize, right? JSONB type adapter, you can switch on adapter using JSONB type adapter annotation on your field, or globally using JSONB config with adapters, and you pass adapter instances there. Serialize and deserialize, even more hardcore stuff. Actually, serializer, it uses JSON generator, so it uses JSON-P stuff itself, right? So if you want to customize serialization or deserialization on really low level, you can create serializer, deserializer for some of your types and access JSON-P stuff directly there, right? Which is quite a powerful mechanism. Internally, for instance, JSON implementation uses that. So to enable it, again, we have a couple of annotations: JSONB type serializer, JSONB type deserializer on the field, or with serializers, with deserializers methods of JSONB config to do runtime customization. There you pass actually instances of your serializer and deserializer. Right, so I finished. So now I'm passing control to Andy, and Andy will talk about the future of JSON binding. Stop sharing. Andy, please.
All right. Thanks, Dmitry. Let me know when you guys can see my screen, okay? I guess, Dmitry, since you have audio. Okay, so picking up with the future JSONB plans. So again, Jakarta EE 8, that's what was released, officially announced today. And that is pretty much what Dmitry has gone over so far. So the things I'll be discussing here will be available hopefully in Jakarta EE 9, which we don't know what date that's planned for yet, but hopefully it'll be coming up soon. So I've kind of categorized the new features into a couple categories, just the big features and small features. And this, what I have on the screen here is just a subset of what we have planned for the next release of JSONB. So I'll jump into a few of these along with code examples and mock-ups of what we think the features will currently look like. So probably the number one most requested feature that we've heard of, or at least I've heard of, for JSONB is the ability to customize third-party classes. So JSONB is essentially broken down into two branches. There's the default mapping, which is you just have plain old Java objects and no references to JSONB annotations anywhere in your code. You don't even need to add the JSONB dependency in your POM or anything. But for customizations are necessary in a lot of cases, especially when your service doesn't necessarily control the type of schema that you are coming in with or have to interchange with. And in some cases, the model objects might not be under your control. So if the object, the Java class that you're trying to convert to and from JSON is you don't have edit access to that, or it comes from a binary dependency, we call that a third-party class. So taking inspiration from Jackson, which is another library that does JSON mapping, although it's not JSONB compatible, we've come up with this approach here to basically customize everything you can do with JSONB annotations, except to do it in a programmatic way. So in the top right-hand corner, I have a dog class, and I want to change the name field to be dog name, and I want to ignore the owner field because maybe I don't want that information in my JSON. So using this new proposed class customization class, we can define property name changes and which properties are transient, and then along with support for any other thing you can possibly do with JSONB annotations. And then this would be configured with the JSONB config object, which is already a class that exists in JSONB 1.0. So moving on to the next large feature is polymorphic deserialization. So if you have an interface with multiple implementing classes, it's not possible for any library such as JSONB to know what concrete implementation should be used to instantiate that object. Sometimes you may want an extra attribute added in your JSON data to indicate what concrete object should be used during serialization or deserialization. And to accomplish that, we've proposed an extra polymorphic config class, which will allow you to configure the concrete implementation classes such as dog and cat, and then optionally the type attribute that you want to carry the name of the implementation class. So that will be an optional configuration. I think it'll default to something like Jakarta.JSONB class or something equivalent. Oh, and I'll also mention that polymorphic deserialization is possible today with JSONB 1.0 using a custom adapter, but like Dmitry said, that's for more, adapters are kind of for hardcore users, and there's a lot of code involved in writing adapters and serializers. So it's nice to cover these common use cases with less code where we can. So another big pattern, I think this is the last large feature that I have on the slide deck, is custom constructors with absent parameters. So if any of you have ever used tools like Lombok, where you have like an all-args constructor, which basically means, or immutables, that's another library, I think it's org.immutables. for immutable objects, you need to have final fields for all of your data. And usually those type of objects are instantiated either with a builder, which is kind of, can be a lot of code overhead, or simply an all args constructor, which is what I have shown on the right-hand side here. But it's not always necessary to instantiate an object by supplying every single parameter. And currently JSONB 1.0 can't do that. For example, if I receive the JSON on the bottom left here with just first name and last name, but there's no middle name present, currently that would fail. In the future, we'd like to define some sort of rules that would say, pass in a null for the middle name, for example. So that way you can easily construct immutable objects without needing to worry about custom adapters or custom serializers. So now we're on to the minor customizations here. So these will be, the minor enhancements, which will be pretty quick. One thing is when you write an adapter class, it's there, you've written it, but you need to also take the extra step to register it with your JSONB config. One thing we can do when CDI is present is we can add an annotation to the adapter class and automatically register that adapter with the JSONB config that's being used. So another one here is called the must ignore policy. So by default, if a JSON property is not present in the JSON, JSONB will simply ignore it. And that's the default behavior. For other libraries that deal with Jackson with JSON binding, such as Jackson, you might want the behavior where if you see an unrecognized field, you want to know about that instead of silently not initializing that field. Maybe your JSON schema has changed and you want to be able to catch that in your test phase. So we proposed adding this new configuration option for rejecting unrecognized fields. And when that happens, when you try to convert from a JSON string to a Java object and there are unrecognized properties in the JSON, then an error would be raised instead of simply ignoring it. So what I have here is that's just kind of a preview, a subset of all the features that we have planned for the next version of JSONB. If you want to check out all of the features that we have, you can go to this link, and I think Dmitry will make the slides available. But we have all of the features, big and small, planned for the next version of JSONB out on a publicly viewable GitHub board. You can't edit it, but you can see what priority things, different issues are at, and you can upvote or downvote different issues, or you can comment on issues you care about to potentially influence the design. So I really want to encourage people that do have ideas or questions about potential features for JSONB, please go to the project board and take a look at what we have planned and give us your comments. So with that, I will end out the broadcast, and then I think we have a few questions in the chat. So I'll go through those quick. So Dmitry, if you want to start unmuting yourself, I can cover the JSONB questions and I'll let you cover the JSONP questions. So first question is from Reza. He says, is it too early to evaluate including JSON schema support? It's not an RFC yet, but it's pretty widely used. So Dmitry, I see you said that's out of scope for 1.0. We do have I think we do have a issue open for schema support on the JSONB GitHub repo. I think it's in the might do column, but certainly what we do and don't do is influenced by users such as yourself. So if you care about this feature, go ahead and give the GitHub issue a thumbs up or a comment that you would like to see it, and we'll take that into consideration when prioritizing issues. So next one is from Werner. Are there plans to add an instantiable factory to JSON processing, similar to the JSONB class in JSON binding? So Dmitry, I'll let you answer that one since it's a JSONP.
Again, I can answer the same thing. So, Werner, if you would like to see this feature, just go to our wishes tracker, explain exactly what you want to add, and we will evaluate it. Right. So we are quite open. We are collecting new features for JSON-P too. There are not many new suggestions as in JSON binding, but we are planning to release a new version of the spec. So feel free to make your suggestions.
All right. Next question is, we have JasonB and we have JaxB. When do we choose one over the other? So the comment here is correct. So when you're using JSON, you use JasonB for JSON data, and you use JaxB if you're working with XML data. So the question of whether you're using JSON or XML is totally up to your business, and what especially if you're using like a microservice architecture or some sort of inter-process communication, you need to work that out with the other services to kind of establish a communication format, whether you want to use XML, JSON, or some other format. But when you're using JSON, JasonB is the ideal solution. I think we already answered that one from Werner, so I'll skip that. Another one from Werner. So the question about Java Money support in Jakarta EE. Hibernate Validator has public pluggable support for data types like money and currency. Could you imagine something similar in the JasonB implementation? Personally, I haven't seen much demand for the money API. There are the adapters that Dmitry mentioned in his slides that you can certainly write for adapting between JasonB and the money objects. But yeah, that would be my recommendation for now. And we don't have any plans to make explicit support for the money API in the future, because really Jakarta specs can only depend on things in Java SE or other Jakarta specs. If there were to be any sort of interaction between JasonB and the money API, it would have to be some sort of third-party module, which I'm not against by any means, but it just couldn't be in the official JasonB spec. And I think that's all the questions. So with that, we got 3 minutes left. Thanks everyone for attending, and we will see you in the next session.
Yeah, just a little comment. I posted a link to the slides. I just uploaded to SlideShare. So feel free to browse it, and feel free to participate in the new version of the spec. Thank you very much.
Thanks. Bye.
Bye.